Good evening and once again welcome to my YouTube channel, Pearson with Excel International Maths and Takamoto. And in this video I want to explain example 3 of Pure Mathematics 4, and we continue to understand the topic number 6, which is integration. And we've just introduced ourselves to how we get the volume of a strip when it is rotated around the x-axis, and we are now faced with a question that is asking us to apply just that. And what we have here is the diagram shows the region R, which is bounded by the x-axis, the y-axis, and the curve y is equals to 9 minus x squared, and the region is rotated through 2 pi radians about the x-axis. Find the exact volume of the solid. We know that the volume is given by pi, the integral of from the limit a to b of y squared with respect to x. And as much as we have the function, which is 9 minus x squared, and we have the limit 1 being equals to 0, we do not exactly understand the upper limit, which is at this particular point. So the only thing that we need to do is to simply solve this equation when it is exactly equals to 0, because anything along the x-axis y is equals to 0, and therefore we have 9 minus x squared is equals to 0, and this means that x squared is equals to 9 and x is equals to plus or minus 3. And because we can already see that x is greater than 0, so the perfect value of x is simply 3. So this point is having the coordinate 3, 0. And at that point we wish now to substitute everything in the formula, whereby we get the volume. Volume is therefore given by pi, the integral from the limit 0 to 3. Why we are having 0 to 3 is because the whole of this region is rotated along the x-axis, and you'll see that this one will take shape to a certain point, and the whole of this region will appear to be containing some volume, of course. 0 to 3 of the y squared, whereby y is 9 minus x squared. This one already squared with respect to x. And at that point we may wish now to expand this particular part so that we can have polynomial terms, or terms that are very independent. 9 minus x squared is simply 9 minus x squared multiplied by itself, which gives us 81 minus 9x squared minus 9x squared plus x raised to power 4, and entirely we have 81 minus 18x squared plus x raised to power 4. And this is now what we need to integrate with the limits of 0 to 3, 81 minus 18x squared plus x to power 4, of course with respect to x. And at that point there is of course pi, so we need to integrate this part, which gives us the integral of 81x minus 81x cubed over 3 plus x5 over 5, and we have now we have the limit 3 and 0. What we have, this is not 81 but 18. This is 18, not 81. And of course when it is 18, then the volume becomes pi 81x minus 6x cubed plus x5 over 5, 0 to 3. And we just have to substitute the upper limit minus the lower limit, and we have this is 81 times 3 is 243 40 minus times x cubed, which is 27. We have 162, that is minus 62 plus 3 raised to power 5, which is equals to that. Of course, when you divide that by 5, it gives you 243 over 5, which is 243 over 5 minus, this becomes 0, 0, 0, minus 0 entirely. So the final submission becomes something that we have 243 plus over 5 plus 243 minus 162 equals to 648 over 5, of course minus 0, and don't forget there is a pi there, so we have 648 pi all over 5, and that is the exact volume of cos unit cubed. So yes, that is exactly what we have been able to do. Please remember, we could not work without the lower limit, which is clear here, and the upper limit. Of course, we know the functions is here, and the formula is very clear there. So that is the end of the story. As far as example 3 is concerned, please make sure you subscribe to my YouTube channel and share widely so that we can work together. All right.